Is the point 7, 15 on this line? One way to solve this is to focus on the x value, x equals 7, and to substitute into here. Y equals 3x, which happens to be 7, plus 2. So the y value we're expecting is 21 plus 2 is 23. Now we see the y value here as 15, so something is wrong. So we say no, this point is not on the line. This here is your x value and this here is your y value. Another way of thinking about this is we can state the question. Does left side equals right side? We substitute into y 15 and we ask the question, does 15 equal 3x plus 2? And the x value here is 7. We draw a line and we state the obvious. Left side equals 15 and the right side is 3 times 7, which is 21, plus 2 is 23. Left side does not equals to right side, so therefore this point is not on the line. Now let's work on this point here. We have the x value of negative 5 and the y value of negative 13. Let's substitute negative 5 into y equals 3x plus 2, the line equation. What y value are we expecting? We have 3 times negative 5 plus 2, which is negative 15, plus 2 is negative 13. Indeed, we have the correct y value, so we say yes, it is on the line. Now what is the y value f when x equals 5? F of x is your y value, equals 3x plus 2. When x equals 5, we replace x with 5. We substitute. So f of 5, essentially your y value, is 15 plus 2, which is 17. So the answer is 17. Is this line the same as this line here? Let's begin by looking at 0.6 repeater. 0.6 repeater is the same thing as 2/3. Recall that 0.3 repeater is 1/3, which is 33.3 repeater percent. So here we rewrite this as y equals negative 2/3 x plus 1/5. We call this the slope intercept form, whereas this here is called the general form. Let's multiply by the LCM. 3 times 5 is 15. We have 15y equals 15 times negative 2/3 x plus 15 times 1/5. We have 15y equals 15 divided by 3 is 5 times negative 2 is negative 10 x plus 15 over 5 is 3. Let's throw everything to the left. We have 15y and this negative 10x becomes a positive 10x. And when we throw the 3 over, we get negative 3 equals 0. So these 3 terms equal 0, which is the same thing as saying 0 equals 10x plus 15y minus 3. So indeed, these two lines are the same. Given h of t equals 2 minus 4t, evaluate h of negative 2. What we do here is we substitute the t value of negative 2 into here. So h of negative 2 equals 2 minus 4 times negative 2. A negative times a negative is positive, and 4 times 2 is 8. So h equals 10. This question is very similar to f of x equals 2 minus 4x. Evaluate f of negative 2. We're used to f of x as your y value. We can even rearrange terms. So we have negative 4x plus 2, and we're trying to find the y value when x equals negative 2. So y equals negative 4, bracket negative 2, plus 2. So y equals negative times negative is positive, 8 plus 2, which is 10.